Okay, we're going to wrap up quadrilaterals today by talking about trapezoids. I know on lesson 1 you guys also had kites. Kites aren't really something that you see all too often, and to be honest, I just don't think it's really that important or relevant. But there are some properties about kites we may need to revisit before the end of the year. But let's wrap it up today by talking about trapezoids. So what we know about trapezoids, if you remember from the family tree, is that they are not parallelograms. So you've got quadrilaterals, and it kind of breaks off into two parts, which are parallelograms and trapezoids. So this is what we know. If a quadrilateral has one pair of parallel sides, parallelograms have two, right? Then it's not a parallelogram, it's a trapezoid. Trapezoids don't have too many properties on their own, so today we're going to actually look specifically at isosceles trapezoids. So trapezoids, when y'all think of a trapezoid, and if I were to be like, hey, so-and-so, draw me a trapezoid on the backboard, most of you would draw an isosceles one. That is your elementary teacher's fault. They probably showed you nothing but isosceles trapezoids, but a trapezoid just has to have like two parallel sides, and then this side could come down, this side could come out. It doesn't matter as long as these two are parallel. Now that does not look like an isosceles trapezoid, okay? An isosceles trapezoid is a trapezoid where the base angles are congruent. So it says a quadrilateral is an isosceles trapezoid if the base angles are congruent. Okay, so just like an isosceles triangle, if I have base angles that are congruent, the sides opposite it are as well. So think about an isosceles triangle. An isosceles trapezoid is really similar. The two sides are congruent, and then the angles across from it. So the sides opposite the two angles are also congruent. So there's two big things about isosceles trapezoids. We are going to do a quick proof today. I'm not going to do any examples. Because you're just setting things equal to 180 and stuff like that. I don't have a ton of practice for that, so I'm going to do this proof, give you two additional properties, and then you guys are just going to practice. So we're going to prove that in this isosceles trapezoid that the base angles are congruent. So we're going to prove that that's true. Not that y'all don't believe me, but let's kind of go through it. So it says, given ABED is a parallelogram. So what you have here is you have a trapezoid. I know it's a trapezoid because it just said ABED is a parallelogram. That means these are parallel, right? And these are parallel. So if these two sides are parallel, then this has to be a trapezoid. So I've got a trapezoid here. It's got a parallelogram inside of it. I'm telling you that AD and BC are congruent. I want to prove that D and C are also congruent. So these two sides are congruent. We want to prove that the angles across from it are. So we want to prove that this little line right here is true. So ABED is a parallelogram. How do I know that? It's given. Okay, this one's like legit fill in the blank. This is exciting. It's already filled in for us. We just need to figure out why it's true. So now that it's a parallelogram, it says angle D and angle BEC are congruent. Why is that true? So what I'm going to do to help y'all visualize it is I'm actually going to extend these sides just a little bit. Okay, and I've got two parallel lines cut by a transversal. These two angles right here are in the same kind of relative position. So here's my two parallel lines cut by a transversal. If you did your packet, the reason why these angles are congruent is because they're called corresponding angles. Okay, corresponding angles are congruent. It says AD is congruent to BE, so this and this are congruent. How do I know that? Well, because it's a parallelogram and opposite sides of a parallelogram are congruent. And then this last one says AD is congruent to BC. Notice that doesn't come from anywhere. That was given to us right here, so this is also given. And I'll label that with another color because things are getting kind of crazy. So this side and that side's congruent, but this side is also congruent to this side. Okay. So let's start here. So if AD and BE are congruent and AD and BC are congruent, okay, what it's saying is BE and BC must be congruent. So one more time. If AD and BC are congruent, so they're red, and then AD and BE are congruent, the blue, the red and the blue over here must be congruent, right? Duh. That's called transitive property. So basically it's saying like, if you look right here, you've got AD and BE, AD and BC. So that means BE and BC must be congruent. You see how they like line up? That property is called transitive property. If you had any time to look at your proof cards, that's a Math 2 thing. So one more time, if the blue are congruent and the red are congruent, then this blue and this red right here must be congruent, right? Okay. Therefore, y'all look at this triangle right here. I know it's kind of, I know it's kind of crappy looking, but I've got two sides right here that are congruent. What kind of triangle is that? It's an isosceles triangle. Why? That's the definition of an isosceles triangle. Two sides are congruent. All right. So, right here, I think we have another maybe transitive property happening. So it says angle D, gotta slide up, angle D right here, and angle BEC are congruent. All right, angle D and angle BEC are congruent. Well, that means angle D and angle C must be congruent. So I think, oh, that's where we're trying to land. I'm sorry. Y'all, I can't follow my own flow proof. I need to go down and then over. So sorry. So that's probably going to end up being transitive property, but I need to be able to translate it right here. Okay, cool. So here we go. Sorry. Jumping ahead of myself. I've got a triangle right here. It's isosceles because both of these sides are congruent. What do I know about isosceles triangles? We were talking about them yesterday. In an isosceles triangle, these two sides are congruent and the angles across from it are congruent. So it says angle BEC and angle BCE or C, they're congruent. It's the throwback. That is isosceles triangle theorem, or in my Math 2 class we called that ITT, if that sounds familiar. So isosceles triangle theorem says if these two sides are congruent, the angles across from it are. Now, looking at my flow proof coming this direction, if angle D and angle BEC are congruent, and angle BEC and angle C are congruent, then again, transitive property says, oh, D must be congruent to C. Look at my fingers, you guys. If angle D and angle BEC are congruent, and then angle BEC and angle C are congruent, then D and C must be congruent, and that is transitive property. So, ta-da! I know y'all care so much as to why these angles are congruent, but at the end of the day, just kidding, y'all just need to know it. So in an isosceles trapezoid, these two sides are congruent, and the base angles, they're called base angles, are congruent, the angles at the bottom. So when you're doing your practice, let me show you that really quick. You just need to remember, like if this is 45 and this is a base angle and y'all see those tick marks, that's an isosceles trapezoid. If that's 45, that's 45, right? Okay. Now, what about these other angles? So here's some additional properties we're not going to prove. I don't have time. Don't want this video to go too much longer. Some additional properties that are just some things to think about. The base angles are congruent. And so therefore opposite angles in a trapezoid, they're not congruent, they are supplementary. What does that mean? So if you're practicing in your packet, that means they equal 180. I talked about that with parallelograms too. So in a parallelogram, like this one, opposite sides, sorry y'all, opposite sides are congruent, or opposite angles are congruent, and these angles right here are supplementary. But in a trapezoid, an isosceles trapezoid, the base angles are congruent, and these angles right here that are across from each other, they're supplementary. Okay, by default, that means these are also supplementary. So you just need to set, like, if this is 80, this is 100. If this is 80, this is 100, right? Okay. And then the last thing, and this is kind of interesting, is the diagonals in an isosceles trapezoid. I wish I had time to prove this one. They are congruent, like a rectangle. So you're probably seeing, you need to study. In this unit, you're actually going to have 2 days of review because you've got a lot of properties, a lot of things in boxes that y'all need to memorize before your test next week. So just today with isosceles trapezoids, you've got one pair of parallel sides, you've got 2 sides that are congruent, base angles are congruent, opposite angles are supplementary, and diagonals are congruent. So all those things, all 4 of those things, so 1, 2, 3, 4, you need to use when you're doing your practice on the back. Okay, some things are going to be equal, some things are going to be equal to 180, so be careful and make sure you pay attention. Also, I remember number 8 from last year. Number 8 is giving you unnecessary information, so be careful. Okay, read what it says, but think about what you know about an isosceles trapezoid and make sure you're setting the right things equal when you go to solve for x. But this is practice. I do not need to do this. You can work together if you want. This is your homework. They'll check it tomorrow and go over it tomorrow. And you guys are going to have a quiz. Let me explain really quick, and I know they're going to go over that, but you guys are going to have a quiz too, and it is nothing but properties. I'm just telling you straight up. It is literally, which of the following has congruent diagonals, A, B, C, or D? Rhombus, rectangle, blah, blah, blah. It might say, which of the following always? Sometimes. It might say never, like which of the following never has congruent diagonals. So I believe that Miss Robinson or Miss Chisholm are going to give you guys some time to study your boxes and your notes before that quiz, but you literally need to do this practice and just study. Tomorrow's kind of like a glimpse into like what the beginning of the test is going to be like. You need to know your properties. You guys have got to start studying. But we're done. Boom, Unit 7. I will see y'all on Thursday.